Yes. Thank you all so much for coming here. We are Team Tattletell. Now, what is the problem that we aim to solve? Well, maintenance issues. So unfortunately, cities cannot get real-time access to data about smaller things like potholes, overfilled trash cans, broken street lights, fallen trees, but these are things that the city is in charge of taking care of. And so we wanted to have a solution that could help users report real-time data to the cities. So we are community-driven, and our goal is to reduce the recognition and response time of maintenance issues in local infrastructure. Through our app, our local community can report maintenance issues with just the click of a button.
Okay, so our app, we try to make it very simple and very user-friendly. So this is the title screen. When you open the app, you'll be met by this screen, and it tells you the description of our app, how to use it, and we have a button that says take a picture. It will lead you to the camera screen. And the camera screen is very simple. It has a camera view. It shows you what you're taking a picture of, and then there's an outline to show where to put the trash can to get the most accurate picture for our trash can recognition system. And it has a take picture, which takes an image, and then the user is navigated to the preview, and it gives you a preview of it. And you can either upload it if you think it's a good picture, or delete it, and it will take you back to the thing. Once you upload it, it will send you to the back end.
So here, our back end uses our trash can API, where we're gonna take that user's image and evaluate it through 2 AI models. And from those AI models, we're gonna determine exactly which trash can we're looking at, and we're gonna determine what the problem is that we're looking at. Is this trash can too full or is it empty? And after getting that information, we're gonna update our database, which is gonna be a centralized system that keeps track of each and every single trash can in the city and tells you if that trash can is overflowing or not. So we do a dual approach to detect which trash can we're looking at. First, we use geolocation, and from that geolocation, we determine all the trash cans that are near you. So this geolocation isn't good enough on its own because it's not always accurate, especially in a city setting where you might jump around the map even though you're staying still. So combined with that geolocation, we narrow down the trash cans that are near you, and within those trash cans, we have images of those trash cans saved. And we compare our user images to all those images, and we determine exactly which trash can we're looking at. So we know what trash can to update for our database. And the user doesn't have to see any of that. All they do is click a button.
So as reviewed, we have our processing API. This is in Python Flask. This is where our 2 AI models are contained. And we also have our mobile app. So that's built using Dynamic React Native, so it can be used on any platform, Android, iOS, etc. for the image capture, and that image is sent through to the API through our Express backend. We also store the identification data in our SQLite database.
The Tattletell addresses these real-world impacts like the scalability. It need not be just trash management. This can also be scaled to other management maintenance services like traffic maintenance or public property maintenance and so on. We also identify integration potential, like it can be integrated in a public environment or a private sector. Like in an organization, we can use to maintain the organization's services and all those things. And user engagement, like it is very pretty simple. Like the user just takes a photo and just upload it to the server. It's just whoever has a phone can use the application. We understand there is always room for improvement, and we have identified many areas of improvement, and we have listed a few. Like in terms of security, there is always a threat for user data being unsecured. So the areas can be improved. Like user data, their map location data can be secured in a much better way. And also we can also in terms of implementation security, DDoS attack can also be handled. And in terms of model improvement, we used image processing models. So those models can be updated by using more object detection and object extraction and image augmentation models, and fine tuning of the models can be done to improve the better accuracy of the models. And future extension, as I said earlier, like it can be extended to not just trash management, to other areas as well.
All right, so we're gonna start with our app. All right, I'll set it up.
So now we are going to do a quick demo. So here we have a trash can here, and I'm going to take a picture. As you guys can see, now we have a picture of the trash can, and we are going to upload to our database. Yeah, and it received the message, and it has the location information. Like before, our user using the app, our app asks the user to give access to their location data. Yeah, and it's narrowed down to the image folders to compare and identify the nearby trash cans. And by comparing trash cans, we can identify whether the trash can is full or not. It may take some time.
Yeah, so while this loads, this is gonna happen in a server that either the city hosts or a private company is hosting for the city, and it'll process in the background, so the user doesn't need to experience these wait times. Because they're just gonna send a picture, and that picture is gonna be put in the queue, processed, and we see that we found our exact trash can match, trash can ID number 16. So this is Tattletell, seamless, automated, and scalable solution for smart cities to keep track of all our trash and maintenance.